Students, welcome to Micro classes. And in advanced welding technology, we have started discussing the different welding processes, mainly the common processes like arc welding processes, MIG, TIG, SAW, and many other processes. But previously, I have discussed with you the different joints that are very important for your semester examinations as well as university examinations. And today we will be having a discussion on different welding processes that are being widely used in practical applications. Okay, so let us begin today's online session. So today we are going to have a discussion on different types of welding processes that are being widely used in our different industries as well as workshops. And previously I have got, you can see the picture over here. This is a typical diagram of you can say the arc welding process as well, or shielded metal arc welding, better you can say. So previously we have discussed this diagram elaborately. Just to recapitulate to you once more, I am reading this out. Look, this is the electrode wire. It is a coated one. It is written over here as the shielded or heavy coating, you can see over here. And here is the gaseous shield. This gaseous shield is done to protect the molten metal from oxidization by the atmospheric oxygen present around the surface of it. Okay, so generally helium, argon, carbon dioxide are mainly used as gaseous shield, gaseous inert for inert gases. Okay, so here you will find the crater, that is the molten metal is produced over here due to the intense heating of this spark generation between the electrode and the workpiece over here. Okay, now here you will find the slag formation just above the surface of the welding, and after the welding being performed, the slag being removed. Okay, and one more thing, this is the penetration depth, you can see over here, and this is the molten weld metal. This is the weld deposited, this is the base metal, this whole thing is the base metal. Okay, now let us come to the principle of welding. Look what happens in electric arc welding. In welding, actually what happens, generation of heat by an electric arc is one of the most efficient methods. Approximately 50% of the energy is liberated in the form of heat. The electric arc welding process makes use of the heat produced by the electric arc to fusion weld metallic pieces. This is one of the most widely used welding process. As I earlier told you, electric arc welding has got its popularity from ages. Okay, and it is mainly because of the ease of use. You can use it very easily. No such huge skill is required. Setup is also not that much complicated. So it gained its popularity over the ages because of the ease of use and high production rates. That is also very important, as because production rate is directly proportional to the profit earned by individual company. So economically, you can see it is also very much effective process, this arc welding process, electric arc welding. Now if I come to the directly to the principle of arc, that is arc formation. An arc is generated between two conductors of electricity, cathode and anode. You already might have heard the terms cathode and anode. So generally the cathode is kept at negative, connected with the negative terminal of the power supply, and anode with the positive terminal of the power supply. And this is a very common term you might have heard during your chemistry classes. So we have got two conductors of electricity, just like similar to the battery. We have already know the principle of battery from the chemistry classes. So cathode and anode, considering direct current and DC. Okay, so you have to keep in mind, generally we are using DC current. AC current can also be used during welding, but in general we are using this DC current. Okay, now DC current also there are some advantages also, some disadvantages also for DC current as well as for AC current. Also there are some advantages as well as some disadvantages also. Now as far as heating is concerned, DC current is more suitable than AC current, as because it produces the immense heating action. Okay, now if I come to the principle of generation of arc. An arc is generated between two conductors, as I earlier told you, between cathode and anode, considering direct current, when they are touched to establish the flow of current and then separated by a small distance. Okay, so you have to keep a distance. And an arc is a sustained electrical discharge through the ionized gas column called plasma between the two electrodes. Okay, so it is generally believed that electrons liberated from the cathode move toward the anode and are accelerated in their movement. When they strike the anode at high velocity, a large amount of heat is generated, and also when the electrons are moving through the air gap between the electrodes, also called the arc column, they collide with ions in the ionized gas column between the electrodes. The positively charged ions moving from the anode and would be impinging on the cathode, thus liberating heat. About 65 to 75% of the total heat is liberated at the anode by the striking electrons. A temperature of the order of 6000 degrees Celsius is generated at the anode. Okay. In order to produce the arc, the potential difference between the two electrodes should be sufficient to allow them to move across the air gap. The larger air gap requires higher potential differences. If the air gap becomes too large for the voltage, the arc may be extinguished. Here we may make use of an analogy of a person walking on the road. Suddenly, when a deep trench comes in his way, the person would try to jump across it if it is a shorter one. But if it is a broader one, then the person may move back a little, come running towards the trench and try to jump over it. If it is too broad, he may abandon the idea of jumping across it. The energy spent in jumping is much more than what is spent while normal walking. In the case of arc, the extra energy spent crossing the air gap is liberated as heat, as I told you earlier. Heat is generated between the workpiece and the electrode. Okay, so now what I will tell you that an ideal joint between two pieces of metal or plastic can be made by heating the workpieces to a suitable temperature. In other words, on heating, the materials soften sufficiently so that the surfaces fuse together. The bonding force holds the atoms, ions or molecules together in a solid. This bonding on contact is achieved only when the contaminated surface layers on the workpiece are removed, recontamination is avoided, and the two surfaces are made smooth, flat and fit each other exactly. Now, here you can see the picture of a typical welding rods, that is the electrode. We generally call it as electrode, or you can also call it as electrode rods, and on the body you can see there is some engravation markings over here, E6013, 6012, 6010 as well. So this these markings represent the the structure or different characteristics of a electrode or welding rod, whatever you may say. Okay, so this is a typical type of electrode which are being used to produce the arc or the spark between the workpiece and the electrode. Okay, so this is the mouth of the electrode from where the arc is being generated. Okay, now how welding works. Here in this picture you will find a typical diagram of a setup of welding. So here you can see this is the electrode and flux is this one, flux jacket, which will help you to provide the inert atmosphere during welding. This is the filler material inside the coating. So here is the gaseous cloud during the welding. These are metal particles, as you can see. This is the weld scene. The man is performing the welding operation. Here is your transformer, that is the power source. Here is the grounding wire. This is connected with this clamp. This is the electrode lead, this one. So you have to earth during welding for the proper connectivity, which will help you to produce the generation of the arc. Previously we have discussed the different weld joints. Just to let you just to remember once more, I am having this picture of different weld joints. As these are very important, you must keep in mind every time. It will not only help you in securing great marks in university examinations, but also to clear some competitive examinations as well as for gate purposes also. Okay, so look, this is the single V. These are all bar welds mainly. So this is the single V, this is the double V, this is the single U, this is the double U. And for the T welds, here you can find this is the single V. This is the symbol of the T weld, and this is the symbol of the butt weld. And different type of T welds are single bevel. Here you can see the single bevel. Here you can see the double bevel, where the deposition will be here only. Okay, this sides will be depositions only. Okay, single J, here you will find the single J, and the double J, here it is double J. Now the corner welds are this one. Here the deposition will be taking places, this ones. Okay, these are the corner welds. Okay, next is your lap weld. Here you can find the lap weld, and this is the edge weld. Okay, next, coming to the fusion welding, the basic principle is that base metal is melted, filler metal may be added, heat is supplied by various means, that is acetylene gas, or by electric arc, or by plasma arc, or by laser. So here the same picture you can see over here for your clear understanding. This is the filler material, or electrode, or welding rods, whatever you want you can say. And this one is the electrode coating, and inside the electrode coating is the core wire. This is the welding atmosphere that is being produced by the melting of the coating of the electrode. This is the inert atmosphere, you can also say, to protect the welding from being oxidized from the outside atmospheric oxygen. Okay, now this is the arc stream, as you can see over here. This is the arc pool, that is the molten metal pool. Now this is a solidified slag. As I earlier told you, slag is the impurities, that is contaminations present in the welding that are being collected at the top of the welding. Okay, so next is your metal arc welding process. Now in the picture you can see is a similar metal arc welding is more or less similar to the manual metal arc welding or shielded metal arc welding, whatever you want to say. This is a basic arc welding process. Here also we are having the molten metal during the welding process, the spark generation. The immense heating, here the metal becomes melted, and a pool of molten metal is being created over here. So this is the workpiece, this is the gaseous atmosphere, this is metal and slag, this is the arc being produced, you can see over here. So this is the flux, and this is the metal, this is the molten metal, this is the solidified slag that is collected over the welding, and this is the weld. Okay, so it uses an electric arc to coalesce metals. Arc welding is the most common method of welding metals. I already discussed with you. Electricity travels from electrode to base metal to ground. I already told you that the generation of the arc. Okay, now just to have some idea on the arc welding equipment, I must tell you two important points in connection with the arc welding equipment, that is AC machines. There are two type of machines generally for setup of electric power arc welding during arc welding process. So I must tell you, one is your AC machine and another is your DC machine. Okay, so in AC machine we are having transformer. This AC machine we are having transformer and motor or engine driven alternator. So in AC we are having the transformer and alternator. Okay, alternator. And in DC we are having transformer with DC rectifier and motor or engine driven generator. Okay, now what happens, the transformer does not have any moving part and as a result operates with less maintenance cost and also has higher efficiency. The power used is also less expensive and practically there is no noise in operation of the welding transformer. And in AC welding normally only transformers are used. Now in DC arc welding, a rectifier or generator can be used to simply supply the required DC power. What happens in the rectifier type, the power supply is first stepped down by means of a transformer to the required voltage and then silicon controlled rectifiers is used to convert AC to DC. So rectifiers are being used for conversion of AC to DC. You have to keep in mind rectifier, the function of rectifier is very important. Okay, so the rectifiers are very compact, highly reliable and have high efficiency. The other type is a DC generator which is driven by either an induction motor running on AC or an oil engine. This combination is less efficient, more expensive and noisy in operation. Now the welding machines are generally classified into two types based on characteristics. The first one is the constant current welding machines. I must write it for you. First one will be constant current welding machine or droop curve. You can also say droop, DROOP, droop curve machines, or simply you can say droopers. So simply you can say droopers, the first one. Okay, and in this type of welding machines, it vary the welding voltage to account for the change in the arc gap, thus maintaining the arc current. As a result of this, the characteristics of the machine are a drooping one. Okay, and open circuit voltage are kept at 80 volts. Okay, whereas sometimes it is also said to be a 50 volts. Okay, now it can be seen that for a large change in output voltage, the corresponding change in current is so small that the quantity of the weld can be maintained. Okay, this is very essential for manual arc welding processes since the maintenance of the constant arc is nearly impossible by a human welder. Okay, so this is, you need to know about the first type. Okay, and next we have another machine which is known as constant voltage welding machines, which have a more flat characteristics curve. Okay, the slope of the curve is so small that any small change in voltage makes for an extremely large change in output currents. These systems are generally preferred in the automatic machines since they become self-correcting. For example, when the electrode becomes a bit closer to the arc, the arc voltage drops, raising the output current to a very high value. This current instantly melts the electrode and thus maintains the arc gap. Okay, so you have to just know that two welding machines are generally being widely used based on their characteristics. First one is the constant current welding machines or droop curve machines. Okay, or the droopers, simply droopers you can say. And second one is the constant voltage welding machines. Okay, now if I say about the setup of the welding equipments, the currents generally are have a range of 100 to 3600 amperes and the watts are from 1 to 6 in a molten pool. The voltage are being kept somewhat in a small amount, that is 20 to 50 volts, and the speed is generally from 30 to 350 centimeter per minute. Deposition rate is somewhat 2 to 100 kg per hour. Okay. Now coming to a different welding process, that is a resistance spot welding. You know what happens, tips of the two opposing electrodes contact surfaces of lap joint and resistance heating produces a spot weld. Good bond in the weld nugget is obtained by having pressure continually applied till current is turned off. Strength of weld depends on surface roughness and cleanliness of the mating surface. Okay, so we'll be having a different class elaboration of these different welding processes. Today you just know the names of different welding processes that are being widely used, you know, in different purposes. So I'll be just skipping the, you know, description of the different welding processes, and in the later classes, coming classes, we'll be having a class on where we'll discuss in details for the different welding processes. Okay, now next one is your carbon arc welding. Here you will find the carbon arc is most similar to the electric arc welding. Okay, just the electrode is of carbon and is the filler rod where, here is provided is the weld bead, you can see over here, and this was developed in 1884. Okay, next is a shielded metal arc welding. This is more or less similar to the normal arc welding process, as I already discussed with you. You can take a screenshot if you want to have some notes of shielded metal arc welding process. Next we have MIG welding. So MIG welding is also very, you know, widely used metal inert gas welding process. It is also known as gas metal arc welding process, and the, you know, is widely used for different purposes. This MIG and TIG. TIG is also a very you know, a versatile process. So we will be having some classes on this particular MIG and TIG welding process. But if you want to have some notes, quick notes, you can take a screenshot of this particular MIG welding. Next is your TIG welding, tungsten inert gas welding process, where non-consumable electrodes are being widely used, and this question is being widely asked by the competitive examinations. In which welding process non-consumable electrodes are being used? The answer will be TIG welding process. Okay, so look, this tungsten has a high melting point, 3422 degrees Celsius. So here the only the change is that the electrode is non-consumable, so you have to keep in mind, and we will have a class, separate class on detailed discussion of this TIG welding process. Okay, so next is your submerged arc welding. This is also widely being used, this submerged arc welding process, where we will be having a hooper, where from, you know, continuous feed of granular flux will be fed during welding process. This is also versatile you know, welding process, and we'll discuss in our later classes. Next will be the atomic hydrogen welding process, where you know, hydrogen gas will be used in welding process. Next will be the plasma arc welding process, where the molten, you know, form will be, the concentrated plasma arc will be produced. Okay, and it will be the quality of weld will be very, you know, high, and speed will be also very higher. Okay, so this is all for today's class. In the later classes we will be having some more discussion on advanced welding technology. Thank you.